to introduce this wonderful gentleman. He is the founder and CEO of EI3 Corporation. But what's really exciting is we're going to be talking about a new product today. He's going to be talking about, I'm not going to be. He's going to be talking about a new product today. There's a new product out that just hit the market called Connected AI. Could you please put your hands together and give a warm round of applause to the founder and CEO of EI3 Corporation, Mr. Spencer Kramer.
Thank you, Jackie. Can you hear me? Yes. Okay, very good. Yeah, welcome everyone. I want to start with a little admission. This is my first show in over 18 months. First time out on the road. Who else here is the first trade show since the pandemic? Yes, 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 yes. All right, everyone. Good, good. So you'll bear with me if I make a few mistakes from my nervous jitters getting back on the stage here. Thank you again for coming to see us at the Pack to the Future stage. What we're going to be talking about is putting AI to work. We're going to take AI, take him out of the school, put on his hard shoes, a hairnet, and a hard hat, and put AI to work in the factory to make sustainable and efficient operations. So it's a broad topic, a lot to talk about. We're going to do this by sharing some success stories, how we've put AI to work in ways that have made very meaningful results for manufacturers who are doing operations just like you. We're going to do this through the lens of the human. If we're talking about AI, we have to remember that people are involved, people are very important, people are the ones who are making these factories work, and people will always have a role. But I've had many business conversations with managers of companies, everything from the corner bakery to the hotel, to factory floors, and I'm hearing the same thing over and over again. I'm hearing that I can't get enough good people. It seems that right now it's very difficult to find the people that we need to build machines, to operate machines, to operate our factory floors. And so when we talk about AI, what we're not talking about is replacing jobs with computers. No, no, no. That's not what this is about. It's really about how can we use technology to create benefits that enable us to produce more and produce more with less. So a couple of statistics. One is that a recent survey was conducted by the US Chamber of Commerce. And in that survey, it came out that 90% of the local Chamber of Commerce chapters said that they felt that they would have more economic growth in their region if there were enough people to fill all the jobs, 90%. Going a step deeper, Deloitte actually put a number on it for manufacturing. Deloitte recently published a report that said that by 2028, manufacturing is going to be faced with a shortage of about 2.4 million jobs. So that's a lot of slots, a lot of jobs to fill, a lot of people that need to be put to work. What is the solution? Well, one solution might be AI. Before we talk about AI from the computer point of view, let's talk about human intelligence. We all know people, right? We are all people here, I hope. Human intelligence, humans are funny, humans are creative, humans can solve problems, humans can follow instructions sometimes, humans can also learn from their past sometimes. The human is ideal for some tasks, but also humans will get distracted, humans can become tired. There's things that humans can't do as well as what artificial intelligence can do. Computers, if you write an algorithm, computers can be relentless. Computers can be there doing the same thing over and over again, and it won't get bored. For example, a computer system can look at every possible outcome of a certain machine operation and assign a probability to what each of those possible outcomes could be and decide if the next outcome, that next thing that happens is within that probability or not. Is it an unusual operation or is it a usual operation? Computers, by doing this, they're also very good at memorizing things. They can remember many more facts about a machine operation than a human can, but they won't have that same intuition. So one of the things that we've been doing a lot with EI3 is blending the human aspects with the computer aspects to create AI that can stretch human expertise as much as possible. Again, going back to that initial labor gap that we're forced with, I think a lot of people in manufacturing especially are seeing this graying of the workforce. So here I am with my gray hair, so I feel like I can talk about it openly and frankly with you. The graying of the workforce is that a lot of the people with the experience are getting ready to retire or are retiring. And how are we going to capture their knowledge and share their knowledge with the organization in a way that keeps that organization running forward in a vital fashion? Well, one of the answers might be AI, and I'm going to show you how. So at EI3, I've been building internet-connected machine systems now for, 22 years. And what we've done is we've created a structure similar to this diagram that you see here, where we have machines, we connect machines, we use the existing PLCs, which are tied into all of the sensors of those digital machines. We create secure ways to allow the data to flow up and out of the machine to dedicated data centers on the internet, a private cloud, where all of that machine data can come and then be analyzed. And for years at EI3, we've been helping. We've connected more than 90,000 machines, devices, PLCs, HMIs in more than 5,000 companies in 100 countries around the world. We're bringing all of this data in. And then what we do is we convert that data into actionable information, things like downtime tracking, production tracking for OEE, fault analysis, life cycle tracking, quality, all of these sort of use cases which are based on measuring what happened, analyzing it, and providing statuses and dashboards to those owners and operators of the machines, and that's been great. And actually for these 20 years, we've been able to build a huge fleet of machines connected for the purpose of building a database that can then be taken to the next level. And what is that next level? Well, the next level is to add connected AI, where we're able to capture the knowledge from the operations of those machines, that local knowledge that's being brought to the machine by that machine operator, and then aggregating that knowledge with the knowledge of other operators at other factories on other machines in a way that we can then return the knowledge back to make those machine operations much more efficient. And that's embodied in a lot of different ways. In fact, the way we like to look at it is through the lens of availability, performance, and quality. And those of you, anybody here a Six Sigma practitioner? Come on, hands. All right. So Six Sigma, you know, availability, performance, quality, that's OEE. Multiply those together. So if you can impact any of those three things, you're going to make your equipment more effective. So far this is all very abstract, and what I want to do is I want to share examples with you so that you can understand how these come together and create that very elusive thing called the ROI. I'm going to start a little bit outside of the packaging industry. I'm going to start with the cement industry. But I'm going to start with it because it really illustrates, this is an actual example from one of our customers where we were able to capture the knowledge and share that knowledge within the organization in a way that creates meaningful results. So imagine, if you would, making cement. Making cement is a process where you're taking limestone and you're baking it and you're grinding it up into a fine powder, adding a few other things, which I don't really even know what it is, but then you end up with a product which will be used for building and constructions, right? Cement. We all know cement. Well, the cement makers brought us in because they felt there was a way that we might be able to help them save energy. And we asked them why, and they said, well, we don't know what's going on here. What we see is that sometimes when we operate the equipment, it's very efficient, and other times it's not as efficient. And we don't understand what's the root cause for that. So we started going deeper into the process, and we got all of the historian data from the settings of the machines, the temperatures and the speeds and the pressures that go into making it. And we also compared those settings to the set point sheets that they use. In fact, probably you all know when you operate a machine, you know recipe controls, right? You have a set of set points that you run to make a particular product. And what we learned was that many of the operators, they would take those official settings and they would tweak them. Humans, again, going to that human intelligence, humans say, I know better. I want to do a better job for my company. I'm going to modify the recipe. I'm going to make this recipe better. And so they would load the recipe from the process system, and then they would make their own manual tweaks. And what we found was amazing. What we learned was that some of the operators would make manual tweaks that would allow those products to be made with adequate product quality, but it was being made with a drastically lower energy consumption than other operators. Other operators would take those same settings and they would change them in the opposite direction. They would make great quality product, but they would use more energy. So in this data science project for this cement manufacturer, what we learned was that the human factor was the greatest degree of variability in the process. And so after doing that analysis and applying these correlations to see, was it weather, was it product, raw materials, was it operator, and learning that it was the operators, what we discovered was that we could capture from those best operators, we could capture what the optimal settings were. And that once we captured those optimal settings, we would be able to share those optimal settings with the other operators. And that do it not in a way that would dehumanize the process. Instead, we would do it in a way that would provide a suggestion tool. So the machine would be running, it's a rainy day, they're having trouble making their quality, and the system pops up a window that says to the operator, we think that this process would benefit by increasing the dryer temperature by 5 degrees. Do you agree? Yes, no. Say yes, increases the temperature, the product quality is maintained, productivity is going, everything is good. So it ends up that by taking that approach and making these recommendations, this one factory, and this factory is not a secret, it's a published success story online, Lafarge-Holcim, Europe's the largest manufacturer of cement, Lafarge-Holcim was able to save in this one factory 18 million euros per year of energy. So now the good news is that those operators who helped with those optimal recipes, they get to the place where they retire or they move on to other jobs to get promoted into a different part of the company, all of the knowledge that they were pouring in from years of experience operating these machines, all of that knowledge is now captured and kept and becomes now part of the AI that makes that process so much better. One example. Another example, which is very relevant, is from a company that is here exhibiting at PAC Expo today. It's a company that makes plastic pallets for shipping things around. You know, when you put product in conveyors and they slide down from one side of the factory to the other, they make those pallets, and they're very good at it. The company is Orbis. It's a division of Menasha Corporation, and my lanyard, which is somewhere over there, has it. So Orbis has been using EI3 for those basic features of production tracking, downtime tracking, and so on for years. and they wanted to take it to the next level. They're a very successful user of EI3 technology. They wanted to see what could we do for them in the realm of predictive maintenance. Of course, everybody who's in IoT talks about predictive maintenance. It is absolutely one of the key use cases that brings a lot of value. If you can replace a part on a machine that is going to break down before the machine breaks down, that replacement of that part is going to be many times less expensive than waiting for the machine to break down and then going to try to find the part, right? It's the old predictive maintenance versus break fix, which one's going to give you the better ROI. Anybody who's been in any industrial classes know we're going with the predictive maintenance. So Orbis wanted to get on board with predictive maintenance, and they did that starting with a product which we've developed together with Millicron, which monitors 3 critical systems of the injection molding machine. Millicron is one of America's oldest machine building companies. They're 135 years old, a great brand, makes excellent quality machines, and has been working with EI3 for a number of years, investing heavily in creating AI-driven predictions on critical machine systems. They look at the heater system, they look at the hydraulic system, and they look at the mechanical systems of the extruder screws and screw tips. And by doing that, what they've been able to do is identify the signatures of machine operations, i.e. what's normal for the machine, and then look at the probability that from that point of a normal operation, what's the next thing that's going to happen? And if what actually does happen fits to it, okay, everything's good, no need to say anything. But if something is not good, we better let somebody know. And so we've piloted 2 years ago. We started on the project a year ago. We had a pilot system. And a few months after that, we had the very first beta version of a production system that would look at the heater bands and it would see, are they healthy or not healthy? And it would use sensors that were already in place to measure things on the machine with a phase angle SCR controller, controlling the power flow to the heater elements. The heater elements themselves are no more complex than the average incandescent light bulb. It's just a resistive heater. What we learned actually in doing this whole process was absolutely stunning to us. What we learned was that, first of all, we could predict, that's not stunning, but we learned that we could predict that the heater band would fail. We could predict it some time before the failure would occur. And we could predict it in a way that we could see that there was a certain amount of hours left before it would burn out completely, much like those of you who have those old incandescent light bulbs. You know how the light bulb burns brighter right before it blows out? Yeah, stuff like that, right? You can predict a resistive element failing if you look at things carefully. But what was really amazing to us was that once we saw it coming, the machine would use a lot more energy. We didn't see that coming. What we learned was that 2 things would happen when those heater band elements were getting ready to fail. One was that the machine cycle time would start to occur because the machine would be compensating for the variability of that heater element. So other heater elements would pick up where that heater element couldn't do the job, but they would have to be compensated by further up and downstream elements and so on. If you think about it, it makes perfect sense, right? The machine was designed with a certain profile and it doesn't have it now. So the cycle time is getting impacted by that. The second thing was that because the cycle time is getting impacted, also the energy consumption of the machine was going up. So to make the same product at the same product quality, the machine was using substantially more energy. And with that more energy being used, we could measure that, and what we discovered was that machine was consuming at a rate of 1,000 kilowatt hours per day, more than a healthy, well-running machine was operating. So now, I see a couple people reaching for their calculators, right? In the Midwest, where these machines are located, they're paying about 11 cents a kilowatt hour. So these machines are consuming more than $100 per day of excess energy. And by doing that, they're creating an ROI for putting the AI-driven heater band detection system in place. Because they have on their shop floor dozens of machines. It's not just one machine, it's many machines, and by keeping these machines running well, a healthy machine is an efficient machine. Makes perfect sense. So that's another very powerful use case, and emboldening us to say that connected AI, this bringing data from equipment, analyzing data in the cloud, coming up with insights, and then alerting, creates value. Now, in the case of, I'm going to back up a slide, in the case of this Millicron product, this is not a pilot offering, this is in production. Jackie very well said that we're announcing today connected AI, and we are. We have at EI3, we've been able to productize the delivery of these AI algorithms so that they're being delivered to the equipment owner at scale. And when I say at scale, it means that we're not just creating algorithms that are running in a bespoke manner on onesie, twosie machines, but instead we're able to empower the entire fleet of machines at this customer and at other customers with this AI feature so that the benefits of these heater band detections are shared by many, many organizations. And that creates profound benefits for all participants, all of the customers of Millicron, because they're able to have this ROI. The other thing about this is that while I show a dashboard here, which is showing the green, yellow, red, i.e. the red, it needs to be replaced now, yellow, replace it soon, and green, it's okay, the reality is that the machine is not showing this as a dashboard to an operator. The reality is the machine is ordering its spare parts directly from the OEM's ERP system, and it goes from a machine event directly to the ERP system without any human eyeballs seeing it or anybody approving anything. It's a preset relationship between the OEM and the machine owner, so that the machine owner knows that these parts will be coming when they're needed and only when they're needed. They save money on their parts warehousing, they save money on unplanned downtime, they gain lots of benefits by having this connected AI delivery method. So I want to finish up with one final story, and I'll make it very brief, but whenever we talk about connected AI, one of the ones that I like to share is Hilton. Hilton has been an EI3 customer for data science-driven alerting for about 20 years. We help them catalog and categorize the energy. We do digital twinning of the energy performance and water performance of their hotel properties. And we help them by identifying which hotel properties are the ones who save the most and which hotel properties waste the most. And then we automatically divert the savings activities to the wasters in a way that they can be encouraged to do the capital improvements necessary to bring the whole fleet of hotels at a higher performance level. That's been working now very well. It's been cited by many organizations as a Energy Leader Product of the Year 2017. It's been cited by Forbes magazine, New York Times, as helping Hilton achieve more than $1 billion of savings for their operational costs of utilities over the past 10 years. So I share that with you just as a point of inspiration to say that it is it's a very powerful way of driving organizational change. Some of you here might be involved with the sustainability, the ESG, environmental, social governance initiatives at large organizations, and you may say, how can we move the needle? We have a giant company. What is the steps that we need to take in order to move that needle? And I can say that we can outline for you a step-by-step process that will work. It will work for you the same way that it's worked for Hilton. And that is to come up with a methodology, a proven methodology that takes it one step at a time. Trial things first. To come up with, sit down together with one of our data scientists and sketch out on a napkin. What is your theory? What would you like to see happen? What are you going to try to do? Do you want to sell more spare parts? Do you want to use less energy in a hotel? Do you want to make cement more effectively? Start with that very big concept and then sketch out an experiment, explore, have the data scientists get your data. It doesn't have to be an EI3 data set. It could be the data that you already have on your historian. We can dig through it. There might be some interesting relationships in the data. And if there are, then we will come back to you with a written proposal which says, by investing the time and effort, we think that we can discover these aspects of your operation that then lead to commercializable solutions. And of course, through that iteration, we can prototype, observe, productize, and go iterations around and around until we get it right. So the results are that these are great tools that can be used to create savings for your organization, whether you're a machine owner, a machine builder, a head of sustainability, a head of ESG, an engineer. You can use these tools to help make your operation more sustainable. Connected AI is a very powerful tool, whether it's hotels, cement, airplanes, machine shops. We have experienced case studies that can help you. So that's what I wanted to share with you here today. I hope you enjoyed it. It's a very future-minded topic on the Pack to the Future stage. I would like to open it up to you to see if you have any thoughts, comments, or questions.
Thank you, Spencer.
Thank you, Jackie.
Wasn't that fantastic? Yeah, he deserves that. That was great.
Thank you.
Okay, you have his undivided attention. You have an audience of one. So would anybody like to ask Spencer any questions? Anybody have any questions?
Have you had any chances to test this with more packaging-specific machines? For example, like a cartoner, looking at downtime on a cartoner and say how maybe the settings on a particular cartoner affect the performance of a cartoner?
So that's a great question and comment, and you actually reminded me of a statement I forgot to make in my presentation, which is it doesn't have to be a fancy application like making cement. It could be the settings on a cartoner or a stretch wrapper, and we have experience with both, where these exact methodologies translate very well to end-of-line equipment. And can have immediately applicable results. We do everything in what we call no-code IoT, so that we would not come to a cartoner application and say, okay, we're going to start with a blank sheet of paper and we're going to develop an application from the ground up. Instead, what we do is we'll take our library of solutions and we'll put our library of solutions to work to help solve your solution so that you can be up and running with an ROI as fast as possible. It's a great comment.
Thank you for that. Anybody else?
I saw a question over here.
Yes? Oh,
Yeah.
yes.
So I see that you partnered with Micron?
Yes.
So how does this work if I'm an equipment manufacturer and want to leverage your services? I don't have my data analyst yet.
Uh-huh.
How do I do this for my customer leveraging your platform?
Certainly. So that's a great question. What the question was, if I'm making equipment similar to Millicron, how could I work with EI3? And so we have a stepwise engagement model. Typically what we would say to an equipment maker, first step is to get as many pieces of your equipment connected as possible. So it might be as you're designing a new range of equipment or your existing equipment that you're shipping, put a connectivity appliance on it, start streaming data out, and then at that same time, talk with us and tell us, what is your goal? Do you want to sell more spare parts? Do you want to have a higher productivity? Do you want to do better service? Our data science team is comprised of people who are skilled, knowledgeable, and experienced at doing machine solutions. They're not coming from the biochemistry lab. They're not coming from the mathematics lab. They are people who work with machines. So they would understand the language of your machine goals and objectives. And actually, quite frankly, we hire people who are fascinated with machines, who are passionate about making machines run better using connected AI. They would talk with you, they would hear your goals, and then they would design those experiments, which would be the start of a journey. At the end of that journey, there may be intellectual property that comes out where we've been working with you, we learned your machines, we have something that might even be patentable. Our typical approach is that we would then, that IP would be yours. It's bespoke development that we do for you. You would then take that IP, we would help you prosecute the patents if you desired, and that you would then have something unique and powerful. We'd love it if you ran it in EI3's framework, but you could also run it in your own framework. You may have another solution, a different cloud, a public cloud instead of a private cloud. We can help you make that happen as well.
Thank you all again for joining us at the Back to the Future stage. Thank you, Spencer, and have a great rest of the show, everyone.